So let's say here log, let's say of something we don't know, some argument there, base 2 equal, let's say 3. Because the question is, what is log in the first place? And sometimes it's confusing if we don't know what it is, right? So this simple example will try to explain that. So if this exponential form, so 3 equal to this log form right here. So it's kind of this thing here is some type of exponent. So 2 to the third power equal to some argument here. And if we do that, 2 to the third power equal 8. So 2 times 2 times 2 equal 8. So here we should have log of 8, 2 equal 3. So this is a simple example to keep in mind when you switch in these forms. So as you see here, this is the base, and when I switched it, it remains as the base. So for log here, this is the base. As you switch it, it's going to be remaining the base. And it's going to equal to that exponent 5. So you see that exponent 3. And the argument now is 32. All right. So that's how kind of gets switched. 2 to the 5th equal 32. And here we usually say if and only if. So I will write it after we do this example. Similarly here, 5, here we're going back to the exponential form, 5 to -1 power there equal to the inside, which is 1/5. And so in general, this definition here can be stated as if you have log of, let's say, b base a equals c, this is, and this, of course, this stands for if and only if. So if and only if, you see the a power c equal b. You know, some books put b here, c here, it doesn't matter. What matters is we need to understand how it works, right? And how to switch back between this exponential form to the logarithmic form and logarithmic form to exponential form. And it's very important to understand that because you will be using it for evaluation, and you'll be using it to solve equations and all that. All right. So here, where we don't have a variable to solve for, but it can be a variable, and so here is just where to put the answers. I put them here. So 5, -1 and stuff. So for example, just do an example here. Solve for x, and you have log of 2. Let's say x plus 1 equal, let's say 2. All right. So if we know this, then we can switch it, right, to exponential form, because we know how to solve the exponential forms. We can just say 2 to the 2nd power there, which is 4, equals to the inside. You see the inside now is x plus 1. So x plus 1 equal 4, which means x equal 3. And you can check this using a calculator. If you do x as 3, it's going to be 4. So, and you can check using the calculator, right? Because 2 squared equal 4, so that's correct. How is this? This also can be connected to the change of base formula. You can check it that way, or you can check it with the calculator if you use change of base formula. If you do log of 4, divide by log of 2, right? This part here. On a calculator, it will give you 2. All right, so I think, yeah, we have some more, and we'll be finished at 29 for this review, and we'll pick up more videos for new topics later on. All right, so you see now, as a quick thing, so if you have these common log, right? That's a common log. And it's not written with any base there because the base is 10. All right. Then if you have ln, or natural log, and it is log with base e. So these two are the two that you have on your calculator. And if you need a different base, then you use a change of base formula. So let's write the change of base formula. Change of base formula is if you have, for example, a and b, so you do log of b over log of a, because you know, you're dividing similar things, then you can use either that or this, or you would get same thing, as long as you use the same log on both numerator and denominator. So change of base formula is helpful when you don't have these two and you need to calculate it, right? So let's say log of base 3 and 5, right? So this is not, it's not on a calculator, so you would use log of 5 divided by log of 3. Okay, so this e thing, right, from here you see that it comes from natural log, so we can rewrite it this way. Since we need logarithmic form, then if we want to do it this way, I'm not sure why it's flickering here. So we need e. As I mentioned, an easy way to, if this gets confusing, is to keep in mind that the e, which is the base here, is still going to be the base here, right? And the y, which is the exponent, is always here the exponent, because you need that, right? And 4 is going to be here to do that. And once we do this, we talked about this log with base e is ln, so we can change it and just say, yeah, we dropped this because it is this. All right, so that's the answer for that one. Then now we're understanding, we're doing the same thing now here. This natural log is log of base e of x equal log x base e equal 3. So e to the third power there equal x. All right. So let's look at this last question here. So this last question is going to be a similar way, where we can ask to what power you raise 8 to get 64, right? And to what power you raise 3, you get 1 over 27. So think about it, just if it's 27, so it'll be 3, right? 3 to the third power equal 27. And when does it happen that you have reciprocal if this is negative? All right, so because that's 1 over 3 to the third, which is 1 over 27. And of course, if you want to also to verify this, since we talked about change of base, I would recommend, of course, to know it this way, but change of base is just a check. Log of 64 divided by log of 8. And or here, if you want to use the ln or natural log, and you will get the two values there.